We've been talking about the scientific method, and today we're going to talk about something that's very similar but not exactly the same, when we refer to that as the engineering method. Now, we mentioned in the past the difference between the engineering method and the scientific method is just that the engineering method has a goal of producing something that's useful and helpful to somebody, essentially. Whereas the scientific method, what you're really trying to find out is you're trying to explain something. You're trying to figure out a principle of nature. So the engineering method, here is an overview of the engineering method, and I'll go through that briefly, and then we'll talk about each of these steps. First of all, you define the problem, then you conduct background research. So that's very similar to the scientific method. The third step is you specify the requirements. This means that there's going to be many requirements, and you're going to have to make sure those are written down. Next, you brainstorm. The fifth is you design a solution. The sixth is you build a prototype. Seventh is you test it. And the eighth is you communicate the results. Now, something really important about this picture right here are these two arrows. Now, you'll notice it has 4, 5, 6, 7, then it's got this arrow going backwards. So what that means is in the real engineering process, we repeat this process, these 4 steps over and over again. We test it, maybe it doesn't meet one of the requirements, so we go back and we do some more brainstorming, we do more designing, we do more prototyping, and we do testing again, and we go back. So that's the key to remember, is that this is not a process that we just finish and we're done. It can go in a cycle many times over. So let me get into just a little bit more detail here. So first of all, how do we define the problem? The problem is just any place we see that there is a need. Here's some examples. People in poor countries cannot access clean water. This is a very common problem, and there are many solutions that have been tried, and to some success, but still is some progress to be made. Another example is drivers cause accidents when they are distracted by cell phones. Okay, so how can we solve that? Well, that's your job if you're the engineer. Or another example is older buildings collapse during earthquakes, another problem that an engineer might try to solve. So there could be millions of different problems that we could come up with just as you go through the day. Whenever you say, boy, I wish, fill in the blank, like, I wish that I had a better cup holder in my car, or I wish that there was something that could keep me cool when I'm out in the hot weather, or I wish that I had a scooter that could power itself. Of course, those do exist, but nonetheless, these are all things that throughout the day, you're always thinking about things where you say, oh, I wish this had this, or different things. And those are all examples of problems an engineer might solve. Number 2 is conduct background research. Now, of course, the whole idea here is you want to make sure that you're not reinventing the wheel. And I like this little statement down here. Let me just move my picture if I can so that we can read it more easily. Okay. It says, learn from the mistakes of others. You can never live long enough to make all of them yourself. So the idea here with researching is it helps us to focus on where the main problems need to be solved. And it helps us to save a lot of time by figuring out what other people have tried and then looking at how we can really improve upon what other people have done. The next step in the engineering method is to specify requirements. Now, requirements are the kind of the describes here. They're the constraints that we have to work within. And when I say constraints, what do I mean by that? Well, let me give you some examples of these different constraints. It might be you have to use only 5 pieces of paper, or this solution must weigh less than 10 kilograms. Or some examples down below, how much weight does the bridge need to hold? It might say the bridge has to hold 10 tons. Okay, that would be a constraint or a requirement. What is the maximum cost for the materials? That could also be a requirement. Cost comes into play a lot when it comes to the engineering method. Or how must the solution protect the environment? There's a lot of things that might accomplish a goal, but if they have side effects that are going to cause a lot of problems, then they're not going to be an adequate solution. So when you start this engineering process, you're going to have this list of requirements that come from whoever you're solving this problem for. And so you need to make sure that whatever solutions you come up with meet all of these requirements. The next step is a fun step. the brainstorming step. This is where you should really sit down and come up with a whole bunch of different ideas. And one of the things that I like to do when I'm brainstorming is I like to come up with an idea and then come up with something that's just about the opposite idea of what you were thinking about before. Okay, so this is a really good method because it makes sure that you don't go down one track and only try one solution. That tends to be a problem with brainstorming, is people come up with one idea and then they never want to leave that idea. So this picture has some other ways to brainstorm and how they come up. One is it came to me in the shower. So it's amazing. Brainstorming comes anywhere, or these ideas come anywhere. So think big but within these crippling constraints. So we have to think big, and that's a really good part of brainstorming. Is a lot of times it's good to at least temporarily ignore some of the requirements and say, okay, if I had endless amounts of resources, what would I come up with? And that helps us to come up with other ideas. So these are other things it mentions here, for example, working together and collaborating, but these are all different ways that we brainstorm. The big thing, though, is make sure you come up with ideas that are completely different from each other, and then, over time, start to limit it down to one or two ideas that you think are going to be the best. So once you have whittled down this idea list to something that you think will work the best, then you need to do your design. Now, this is the part that I see students skip sometimes, but it's very critical. If you don't do a design, you waste a lot of materials. And that's not just in lab class. Lab class, you might be wasting $1 or $2 of materials. But in an actual engineering setting, that could be millions of dollars if you don't come up with a good design. So what a design is a design includes a materials list, a drawing. I should put drawing second, actually, a drawing, and then the measurements for that drawing. Now, the measurements are very important when you make a drawing in our class, otherwise known sometimes as a blueprint. I want to make sure you include measurements. Okay, that tells me that you've really thought this idea through. And then finally, instructions on how to put this together. Now, you don't have to include everything, but at least a general description of what you're going to do in putting this together. So usually when we do an engineering project, I want to see your design before you get started. Okay, and that becomes a good chance to think about some of your assumptions, and a lot of times that designing process, you find you're not just putting down your idea on paper, you're actually revising it as you get it in front of you and you start to see ways to improve it. Here's an example of a blueprint or a drawing design that I just found online, and it's how to make a birdhouse. So you can see these are some elements you want to have in your design. Now, your design doesn't have to be quite this professionally done necessarily, but there's a few things you definitely want to make sure you include. First of all, you have the materials here, and then you notice how you have these measurements that you've made for each of the key elements of that design. And it also has some instructions on how this design comes together. So this is the type of thing that you want to include. And when I'm looking at your engineering project report, I'm going to be looking to see, hey, did you have that materials list? Did you show some measurements so we get an idea of how this is going to come together? And did you have a few instructions? And that's really what we're looking for. It doesn't have to be perfect by any means. But at least I want to say, hey, when you start making your solution, you started with something on paper that you're following, so you're not wasting a lot of materials. Okay, the next part is also a fun part. This is when you actually get to build your prototype. So a prototype is essentially it's essentially just a simple version of your solution. So it's oftentimes, this might be like a miniature car that you build, or it might just be something that you build, using simpler materials. But that's your prototype. It's when you're actually building your solution to see if it works. So we have a cartoon here from the far side. It says early experiments in transportation. So you can see this was maybe the original design for the wheel, and you can see that maybe it had a problem or two that might come up in the next step, which is going to be your testing. So during prototyping, you're just building your actual solution or your little invention or whatever it is. Okay, and then the next step is a really important step. You need to test your solution. Okay, and so you should have tests that are set up. And when I worked in technology, these tests might have been many pages long that you would conduct. And there's a whole career where you become a tester of software. There's also another term for that, but actually we won't go into that right now. But they'll have pages and pages that they follow. Let's say they're testing a video game. They have pages and pages they follow about each of the tests that they have to perform to ensure that that video game is working properly. When we're testing our solution, we want to make sure that we record data for every test. Did it pass it? Did it fail it? If it failed it, what needs to change? And then finally, we compare that data to our specifications, and that's how we decide if it's meeting those specifications or not. Now we have another Far Side cartoon here at the bottom. It says, on October 23rd, 1927, 3 days after its invention, the first rubber band is tested. So there's how that first rubber band was tested. Somebody had to flip it at somebody else's head. And of course, that test has been conducted millions of times since then, including in my household. Okay, and then finally, when we have finished the testing, most likely the next step is that you return to the brainstorming phase. Okay, and this cycle may repeat hundreds of times. I have down here many examples of the first light bulb. And these were, you've probably heard the story. In fact, we're going to have a little project on this, a little research project on this. But when Thomas Edison made the first light bulb, he tried literally hundreds and hundreds of designs, and before finally getting something that was going to work for their purposes and meet their specifications. And then finally, communicate the results. Okay, this is kind of like your conclusion. Okay. But in an engineering project, it's a little bit different. Okay, so first of all, did your solution meet the specifications? Okay, and then when you answer that question, you need to make sure that you provide evidence. Okay, so you should say, yes, it met all of the specifications, and here is the test results to show that it successfully met those. And then next, you should put what future improvements you think ought to be made to this design. What are some things that would make it better? So once you have communicated those results, then you have completed that engineering process. And this is a process that could go on literally for years. In our class, the most we'll do it is maybe 3 or 4 days because we have limited time, obviously, that we can put into this. But I think we'll have a ton of fun with the engineering projects. This is one of my favorite parts of our Earth and Space Science class. What I want you to do, please, hopefully going through this and answering the questions has helped you to get some more familiarity with the engineering process. I also want you to look at the PowerPoint that I've posted on this assignment because you'll want to use this in the future when you write up your report on your engineering project. Good luck with your inventions in this class, and I'm excited to see some of the great ideas you'll come up with.